Welcome back. Let's look at an example of what we would kind of see if we were using the root zero method to solve an inequality graphically. So these questions that are posed to you, we could kind of think of it as if we were graphing in our calculator. If we only have one equation to graph, then it's really just looking at what is y1. But in this case, the way we refer to it, if we don't have a graphing calculator, it's really just the graph of y equals f of x. So you can either refer to that as f of x, or you can refer to it as a y value. So if I could look at part A, we're looking for when is y less than or equal to 0. And part B, another way to say f of x, when is y greater than or equal to 0. So when we were using the root zero method, the main idea was for us to figure out where the x-intercept was, or where the 0 was, or root. They're all meaning the same thing. So just remember, kind of keep that in mind. You might want to write this down. We kind of are more used to it as x-intercept, but that means the same thing as what we call a 0, which means the same thing as a root. They all are referred to in different times. Same thing. So what we want to look at is, where is that x-intercept? And it tells us right here, but we can actually visualize it and see, oh yeah, x equals +7. And so what this value does is it is very important because it breaks the x-axis up into two regions. All the numbers that are before the 7, and all the numbers that are after the 7. Kind of like what we did in intersection method, except there's less lines to worry about, just one function on our screen. So when we're trying to read what region to take, we really want to choose the x values such that we are describing the particular y values. So a lot of times when I compare things to 0, if you're below 0, some people might refer to it as where are your, or I should say, what x values give me, I'm going to move this over just a little bit. So less than 0 means you're on the left of the 0. We would be looking at negative y values. I'll squeeze that in just a little bit. And if we want to interpret this in terms of looking at the part B, the question you have to ask yourself is, what x values give me positive y values? And if we're answering those questions, when you want to talk about a negative y value or a positive y value, what you're really trying to determine is what y values are you looking at when you're above the x-axis or below the x-axis. So negative y values, those are values that are below the x-axis. And positive y values are above the x-axis. And I know you're kind of used to that, but sometimes we don't think about it that way. So I just want to connect all of those ideas that you've probably had just to kind of put them in one place. So let's look at this one more time. If we're going to look at maybe trying to determine what region, let's just pick a test point and then we can decide whether part A or part B fits. So I'm going to look at what's happening in the yellow region. If I pick a random x value, I have to find its corresponding y value. So I map it to where the function is, and I notice that that particular y value, we can actually name it, but your question is it a positive x value or a negative x value? And you can kind of map it back to the y-axis and you say, oh yeah, well, we kind of know that when they're above the origin, that means that they're positive. So just kind of a little note to yourself, it's a positive y value. And yeah, you can pick another x value if you'd like. closer or further away. But when you map it to the function itself, you'll notice that that y value is above the x-axis. So again, it's positive. So the more test points you pick in the yellow region, they seem to be giving us positive y values. So if I'm trying to determine is that part A or part B, I have to kind of go back to my language and say, okay, f of x is positive or greater than 0, means y is greater than 0, and y is greater than 0 when they have positive values. So that would mean actually part B is the winner in this case. The x values in the yellow region are going to describe the part B. So that is all the numbers to the left of 7. So if we want to write that in, that would be negative infinity to positive 7. Infinity has a parenthesis. And because our inequality symbol had a greater than or equal to, that's where the bracket comes into play. I really exaggerate my brackets, but if you're typing them in, no one will have to worry about that. So probably you can guess, okay, if I answered what the yellow region was, then the turquoise region must be the answer to part A, because it's just the flip side. But let's test it out ourselves. Don't always assume. But let's pick an x value. So I'm picking an x value in that region. I notice I have to map it downwards in order to get to the function. And if you're looking at that particular y value, is it a positive y value or a negative y value? Well, it's a y value below the x-axis, so it's actually a negative y value. And then if you kind of say, okay, what does it mean to be a negative y value? That means y is less than 0, or if we want to talk about the function notation, f of x is less than 0. So that means if we're describing all these x values that make negative y values, we should be describing all the numbers to the right of 7. So it's going to give us 7 to positive infinity. And here we have that answer. I did exaggerate that bracket just a little too much. Let's kind of make it a little nicer. So take time with the test points. Again, don't always assume what direction it's pointing is giving you the right region. Notice it was kind of switched in example 8. But let's look at example 9, kind of with the same idea. And again, we are looking at the linear function y equals f of x. So the name of this line is y, or f of x. And if this was a calculator, you probably would have a y1 going on, but we'll erase that for now. So we want to care about where is y equal to f of x. And if we're trying to do the comparison, a little note to ourselves, kind of like what I did earlier. Here we're kind of always looking about when is f of x or y less than 0. Here we're looking at y is greater than 0. But before you even can answer those inequality questions, you have to solve the related I'm stuttering, excuse me, y equality. There's no one in front of me, but I'm still nervous. Oh well, we work on this. So anytime you solve the inequalities, you have to know what the solution to the equality is before you can name the side of x that you're going to be on. So y equals 0 when, we kind of can see it right here, when x equals -2. And if we were solving this graphically, we kind of can tell in the information that it gives us in the lower window. So just kind of a note to yourself, y equals 0 when x equals -2. And that reminds us about the boundary point. And that boundary point, again, breaks up the x-axis into 2 separate regions. Numbers to the left of that point and numbers to the right of that point. Let me redraw that. A little shaky. Here we go. Numbers to the left of that point and numbers to the right of that point. So again, if you're kind of looking at this, I kind of go with a test point, and I will pick a number, an x value in the yellow region. And in order for me to reach my function, you notice you have to map it downwards. And so then you have to understand when you mapped it downwards, what kind of y value were you getting? Is it positive y value or a negative y value? You can even pick another x value to kind of see like, oh yeah, still got to map downwards. And those y values, when you try to figure out what they are, you don't even have to really know their actual value, but we are kind of determining that they are giving us negative y values. So if we have negative y values, another way to describe that is y is less than 0, or f of x is less than 0. So this is going to help us out a little bit and understand that the answer to part B is actually the x values in the yellow region. So if we want to answer that question for ourselves, talk about interval notation, negative infinity to negative 2. And in this case, because of the inequality symbol, we both have parentheses on each of them. Well, infinity always has parentheses, but we're talking about the boundary point now. So now you can say, okay, I got half of the problem done. I'm almost done. It's probably true that the teal region is describing part A, but we want to be careful and we want to make test points. When the functions get a little more complicated, you're going to want to check. So pick a test point in the teal region, figure out where it maps to. Notice we have to go up to find the corresponding y value. And then when you kind of understand what that y value is, it's actually a value above the x-axis. It's a positive y value. So that's kind of answering the question. If you want to be sure, pick another one and another one, just to kind of see what kind of values are you getting for those corresponding x values. Then you kind of see, oh yeah, no matter what I do, if I choose an x value in that region, that y value is always going to be positive. Positive y values are another way to say greater than 0. So if we want to name our teal region, all those particular x values are, where we have it, all those particular x values, they're going to name that teal region. We're going from -2 to positive infinity. So now that we have the right regions, sometimes I get excited and I say, okay, I'm done. I can stop the test. But please reread the directions one more time. And if you can find out what we might be missing, refer to the graph of the linear function y equals f of x and find the values of x that satisfy the following. Okay, feel pretty good that I've described the right regions. But then there's one little thing that we missed. That's why I always kind of like to read the directions over again. Write your answers in set notation. So if we kind of know the corresponding set notation to the interval notation, that is fine. Let's look at this one more time. And we say, okay, how do we describe everyone in the teal region? Well, if we're going from -2 to infinity, that would actually give us, and let me kind of erase it so we have some proper values. Oops, I want to make sure. X is bigger than 2 or less than the 2. It's to the right, so it's greater than the -2. And so that's kind of partial set notation. That's kind of the main idea. But the real set notation always starts off with what variable were you using? Well, we're solving for x. So it's x such that this inequality is true. And then we use braces to enclose our statement. So that is our set notation. Okay, so I can do the same thing for the yellow region. Practice this. Sometimes if I know what region I'm picking, it's really helpful. That's why I kind of think in interval notation first and I go backwards, but you might go the other way, no problem. So if I'm going to describe this yellow region, I am describing the region to the left of the -2. And those are numbers that are smaller than -2. So I know to say x is less than -2. And so that's the main idea. But if you're trying to understand set notation and be formal, you're trying to say, what letters am I solving for? Well, I was solving for x, so that's why we were trying to state that at the beginning. So x such that x is less than -2. And remember with set notation, you always use set braces. And so that would be our answers in set notation. That's pretty good. Let's make sure we can do that for the other one just in case, because I have a feeling, yeah, we ignored it. You should have stopped me. Oh, wait. Anyways, again, remember, when you think you're done, read the directions one more time and then kind of notice if you missed anything. So if I'm looking at part A and I'm describing the teal region, let's do this a little nicer. We're going to look at the numbers or the x values to the right of the 7. So when you're looking at to the right of the 7, we're actually going to look at x is greater than 7. And actually it should be greater than equal to because of the inequality symbol. And now when we talk about set notation and being formal, we have x such that, and then don't forget the set braces to close off everyone. Let's do this one more time. We're going to look at the f of x is greater than or equal to 0. And these are numbers to the left of the 7. So that means they're smaller than 7. So x is less than or equal to 7. And if you're using set notation, there's the x such that, and close it in braces. So now we can feel pretty good about having correct answer. So this is good. So just remember, sometimes we're partial to certain methods, whether you're trying to use the intersection method or the root 0 method. I would kind of like to steer you a little closer to the root 0 method, mainly because when the functions get a little more complicated, having more than one function in your viewing screen sometimes gets a little bit harder to read because they cross each other at many different points. So maybe kind of steer your way, know both methods, but maybe look at this one a little bit nicer. So we're going to hit this up again in the next chapter and even chapter 2, chapter 3, and even further. So might as well kind of learn it now and then you'll be in good shape. I'll see you next time.